Awesome. So this video is going to be discussing and explaining the ideal gas law from a qualitative and a quantitative perspective. So in the past couple of videos, we talked about Charles' law, Boyle's law, and Avogadro's law. And these all have the variables of pressure, volume, moles, and temperature at play. But it's not combined into one cohesive um, general equation that we can use, right? So you may have heard the equation Pivnert, or PV equals nRT, where P is pressure, volume, V is volume, N is moles, R is the gas constant, which we'll get to in a minute, and then T is temperature, right? And usually T is going to be in kelvins. So I put in the PHET animation at the University of Colorado. That's a good resource if you want to see how gas law interactions work on a more qualitative level, right? So go check that out for sure. And then we'll talk about the gas constant a little bit. So the gas constant is going to be variable upon which units you're using. So one of the traditional ways is with the liters times ATM divided by moles times Kelvin gas law constant number, right? But there's also an 8.31 a gas constant, I believe, that utilizes joules and moles somehow. But basically, it's going to depend upon the units you're using, right? So we're going to be using R equals 0.08206 liters times ATM divided by moles times K, right? So given enough variables, we can use this ideal gas law in place of the individual gas laws, as long as we have enough information, right? So we're going to do a simple practice problem where we have a given temperature of 0.42, given temperature, sorry, not a given temperature, we have a given amount of moles of 0.42, we have a given pressure of 1.2 ATM, and we have a given volume of 12.1 liters. We are trying to find the temperature in Kelvin, right? So we're going to be using that PV equals nRT, and we're essentially just going to be manipulating that equation so that we can find the temperature in Kelvin. So if you want to pause the video and then come back when you're ready, we'll go over that right now. Right, okay, cool. So like I said, PV equals nRT, we're isolating for T. So we're going to have the product of pressure and volume divided by the product of the amount of moles in the gaseous system times the gas constant, which is 0.0826 liters times ATM divided by moles times K, right? So all we got to do is plug in now. And then we don't have to convert because we're at the optimal SI units we want. And we're going to pop out 440 Kelvin. And then just keep in mind the sig fig rules for multiplication and division here. And keep in mind the sig fig rules for each step you're working in, because it's an easy way to get tripped up when you do it all at once in your calculator. That's most likely not going to give you the correct sig figs. So break it up into chunks. Cool. That's it for this video. Thank you.